Yesterday we looked at imaginary numbers and how you find them using quadratic formula. Warm up. Bella used quadratic formula to find the zeros of a parabola and she came up with this. How many solutions does the quadratic have and how do you know just by looking? Well, we learned that the discriminant tells us how many solutions there are, and if it's negative, there were no real solutions. But yesterday we looked at if there's no real solutions, there's still two imaginary solutions. Okay, so if there's two imaginary solutions, we can find them by simplifying the radical. So let's do that by looking at the square root of negative 24. So we know if it's negative, we can pull out the imaginary number. And then we think, all right, how can we simplify the radical square root of 24? And to do that, we find the biggest square number we can divide 24 by, and that's 4 and 6. So if I rewrite this, this is square root of 4, square root of 6, and then we pulled out the I. So if we rewrite the whole radical, it's x equals 3 plus or minus the square root of 4 is 2, so 2 square root of 6i over 8. And then we looked at simplifying this, so we're going to pull apart these pieces. The first is this fraction 3/8 plus or minus, and we have 2 squared of 6i over 8. We can reduce this fraction, this 2 over 8, by dividing each by 2. And when we get that, our final answer, so we'll leave the 3/8, and we'll have plus or minus, 2 divided by 8 is 1/4, so 2 divided by 2 is 1, 8 divided by 2 is 4, so we have the square root of 6i over 4. And there's our answer. So those are the two imaginary solutions. If a number has an imaginary part, we call it complex numbers. So a complex number has a real number, and we call that part A, so here's the real part. But then if the part with the I, that's called the imaginary part. And if you have a real part, an imaginary part, this is called a complex number. And so where do complex numbers fit in? Well, if we take a look at complex numbers, they have a real part and an imaginary part. In real numbers, what are real numbers? Here's a bunch of real numbers. Irrational numbers are real. Numbers like pi that go on forever and have no repetition in their decimal and no end. Square root of 2 and e, those are all irrational, but they are real numbers. Rational numbers are numbers that can be written as a fraction, so like 1/2, 2, which is 2 over 1, 0.1 repeating, which is 1/9, and so on. So all of these are rational numbers, are real numbers. Integers are real numbers, and those are positive, negative, and negative whole numbers that are not fractions. Whole numbers are real numbers, and so are natural. All right, so these are all real numbers right here. Imaginary numbers are anything with I. So a complex number has a real part and an imaginary part. So today we'll take a look at this. Again, here's a complex number, 12 plus 4i. The real part comes first, so here the 12 is real. The imaginary part is the 4i. All right, so today we're going to look at operations with complex numbers, and to do that, here's the key. You need to remember that that I is that square root of -1, and if we do the square root of -1 times the square root of -1, that does give us -1. So I squared is -1. Again, that comes from the square root of -1 times the square root of -1. The square roots cancel, and we get -1. So if you remember these two things, you can do the quadratic parts with imaginary numbers, and you can do operations with complex numbers. So here's the first operation. You can combine like terms, and complex numbers are like terms. They're like x's. So you can put together the I numbers, and you can put together the real numbers. So when I say simplify this, these two complex numbers, you add the real numbers together. 4 plus 10 is 14. And you add the imaginary numbers together. So you have -7 and 6. So -7 plus 6 is -I. So here's our answer when we've combined like terms. It's a complex number, a real and an imaginary number, but you've combined like terms. All right, let's take a look at number 2. There is a negative here, and if there's no number right after the negative, it's a -1. We're going to distribute that. So we have our 7, and then we have a -1 times a 12, which is -12, and we have a -1 times -8i, which would be a positive 8i. So you do distribute the negative, and then you combine like terms. So here we add together the real numbers. 7 minus 12 is -5, and then plus 8i. Okay, let's take a look at the next one. Again, we have to distribute. So we have 4 times 13, which is 52, plus 4 times 3i. We can multiply those together. That is 12i. And then we still have that plus 6i hanging out at the end. And now we can combine like terms. We add together the imaginary numbers. We get 52 plus 18i. Okay. Let's look at this one. Okay, we got to distribute first. We've got to distribute. 3 times 2 is 6. Plus we have 12i. Oh, we have to distribute again. There's this negative 1, so we'll distribute. We get negative 5 plus 6i. Okay, combine like terms. So our real numbers here are 6 and negative 5, so that's 1. We have our 12 plus 6i, so that's 18i. Okay, and then multiplying. So if you like FOIL, use FOIL. I like the box. So I have 2 minus 3i. I have 4 plus 7i. So if you remember the multiplying, your binomials here, we have 4 times 2 is 8. 4 times negative 3i is negative 12i. 2 times 7i is 14i. And negative 3i times 7i is negative 21. Oops. I squared. But I squared, remember we said I squared is actually a real number. The I squared is, I could zoom in, negative 1. So let's change that. So this part right here would be negative 21 times negative 1, which is 21. All right, let's combine like terms. Add our real numbers together first. So that would be 8 plus 21, that's 29. And then put together your imaginary numbers. 14 minus 12i is 2i. So you have 29 plus 2i. All right, let's multiply one more. 7 plus 3i squared. Here's what it means. You got 7 plus 3i this way and 7 plus 3i this way. Because it's squared, it means multiply it by itself. All right, let's get this answer. 7 times 7 is 49. 7 times 3i is 21i. 7 times 3i is, again, 21i. And 3i times 3i is 9i squared. Again, when you have an I squared, that I squared is negative 1. 9 times negative 1 is negative 9. So now combine like terms. Let's put together the real numbers first. 49 minus 9 is 40. Add together your imaginary parts, and that would be 42i. So there's our answer. Okay, so you're going to have some simplify the complex numbers and then some review. Again, if you have quadratic formula with a negative number, you need to know how to simplify that. So again, this is you've plugged into quadratic formula. Here's what you get. You should notice there's 2 imaginary solutions, so let's simplify. We have 6 plus or minus. Biggest square number we can divide 44 by is 4. Pull out the I over 4. Let's break it up. So here we have 6 over 4 plus or minus. The square root of 4 is 2. So 2 over 4, square root of 11i. Let's reduce these fractions. 6 over 4 is the same as 3 over 2. 2 over 4 is the same as 1/2, so you have square root of 11i over 2. And those are your 2 answers. We can say x equals. Okay, and then last one. Again, we have that imaginary solution. Let's pull it out and simplify the radical in one step. Biggest square number we can divide 48 by, I think it's, let's try it. It's maybe 16. So let's try it. 48 divided by 16. Yes, it is. It's 16 and 3. So 16 and 3. Pull out the I, and that's over 4. All right, and then here we have, whoops, the color's not that different. Negative 4 plus or minus 4 square root of 3i over 4. Pull apart the fractions. Forgot to change colors. And then here again, any number divided by itself is 1, so these cancel. And you get negative 1 plus or minus the square root of 3i. And those are the 2 imaginary solutions. So your assignment's 2 parts today. Can you simplify the complex numbers, and then can you use quadratic formula?